All right, this video, we are going to convert improper fractions to mixed numbers. Before we do that, I want to make sure that we have a clear understanding of what an improper fraction is and what a mixed number is. So I've wrote some examples here. An improper fraction has a greater numerator than it does denominator. So 7/4, the 7 is greater than the 4. 24/5, 24 is greater than it is 5. So an improper fraction has a greater numerator than denominator. A mixed number is just what it suggests. It's a mixture of two different types of numbers. You have wholes and fractions. So a mixed number is going to take a whole number and write it with a fraction to create a mixed number. So this one we have the whole number of 3 and 2/3 is our fraction. I'm going to be showing you different strategies, but the first one that I want to start with is decomposition. Decomposition is simply breaking down a number, breaking down a fraction, decomposing it into smaller pieces. The opposite of composition. So if you think about what a fraction is composed of, it can help you with decomposition. So I have the fraction 7/5, and it's improper because the 7 is larger than the 5 and it's in the numerator. So if I look over here, if I have fraction tiles, I could compose 7/5 by laying out 1/5, 1/5, 1/5, 1/5, 1/5, 1/5, and 1/5. So 7 1/5 tiles would create 7/5. As an addition problem, as an addition math sentence, it would look like this. 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. So I've decomposed that 7/5 into unit fractions. I chose fifths because of the denominator. The denominator lets me know what fraction, proper fraction, I will use to compose or decompose, whichever you're thinking, 7/5. So now, if I think about what a mixed number is, I know a mixed number has to have wholes and it has to have a fraction. Right now, all I have is fraction. So now I need to take these fractions and I need to identify a whole. I need to find a whole. Well, I know that in fractions, a whole has the same numerator as it does denominator, because that means the whole piece is shaded or the whole pie has been eaten. So that means every piece is accounted for. So since my denominator is 5, that tells me how many pieces my whole is partitioned into, broken down into. So that means I need 5 of these to make a whole. So I'm going to circle 5. Because 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 equals 5/5, which is a whole. I have 2/5 remaining. So that is the fraction of my mixed number. Another way that I can decompose, once I get familiar with the breakdown, this shows it all the way extended, but sometimes that can be a little much when you have larger numbers. So let's look at a larger one. Say I have 12/5. Okay. It will be a lot of work to write out 1/5 12 times. So if I know that my whole would be 5/5, I can work with that. So I know that if I take this fraction, I could compose it of a whole of 5/5 plus 7/12. Because, 7/5. Got ahead of myself. If I take away the 5 12ths, 5/5 from the 12, I will have 7 left. 5 plus 7 is the 12. That's where I'm getting the 7 from. So this is a whole, but I still have an improper fraction. So I must decompose again. I must again think about another whole. So this changes to 5/5, another whole. And now I only have 2 left, because 5/5 plus 2/5 equals 7/5. Now my ending fraction is proper, so I'm finished. So 12/5 equals 1 whole, 2 whole, so 2 wholes, and 2/5. That is using the strategy of decomposition. You can either write it all out, all of your pieces, circle your wholes, or you can think about what a whole looks like and compose your fraction using an addition sentence until you no longer have a mixed or an improper fraction. Let's try one more. (14/3). My whole is going to be 3/3 because I have 3 pieces, and to make it a whole, I have to have all 3 pieces. So if I decompose this fraction using a whole, 3/3, that's my whole. What will be left when I take these 3 pieces out of the 14 that I had originally? There will be 11 left. So this is a decomposition of 14/3 because 3/3 plus 11/3 equals 14/3. This is a whole, but if you notice, 11/3 is still an improper fraction. I cannot leave it this way. So again, I take my whole out. A whole would be 3/3. If I take 3 out of the 11 that I have, I now have 8. All I'm doing is subtracting a whole from the amount of pieces that I have. So 3/3 plus 8/3. Once again, another improper. Break it down again. Take another whole out. Now, I had 8 pieces to begin with, 8 tiles. I took 3 of those tiles to make a whole, so now I only have 5. Yet again, another improper fraction. Break it down again. Take my whole. Same whole every time. I had 5 pieces. I took away 3 of the pieces to make a whole, so now I have 2. I finally do not have an improper fraction. So let's look at the overall scheme here. How many wholes do I have? 1, 2, 3, 4 wholes. And then the ending proper fraction was 2/3. So 14/3 equals 4 2/3. So with the decomposition strategy, your primary goal is to focus on breaking down and decomposing that improper fraction using your whole. And your whole can be found using your denominator. Whatever your denominator is tells you how many pieces are in the whole. Therefore, you have to have all of those pieces to make one. So you would just create a fancy form of one. I call it a FFU. Fancy form of one by putting the same numerator over the denominator based on what your denominator is in your original improper fraction. Hope this helps. This is just one strategy. There'll be another video that shows a different strategy if this is not the one that you choose to use.